Over the last few videos, we've used simple harmonic motion to add some animation to various elements of the force field. We've made our rim glow pulsate and the fill pattern cycle in texture space. In this lesson, let's learn how we can animate the color as well. And we'll do that with an interpolation node that you'll use quite often, and that's the Lerp node. Using Lerp, you can blend between two different values, and in this case, we'll be interpolating colors. Control this with a sine wave, and you can build one more level of complexity into our shader by making our colors animate. Again, these are subtle touches just to make our shader more dynamic and just fun to look at. All right, let's get started. This may be something that we want to reuse, so let's set this up as a subgraph. Right-click, create shader, subgraph, and let's call it color Lerp subgraph. We'll use linear interpolation, and that's where the word Lerp comes from. Open up the subgraph, and we'll begin with an empty window except for our subgraph outputs node. And let's start with two color nodes. Input, basic color, and input, basic color. These will represent our rim glow color, so we'll switch both to HDR just to take advantage of the high dynamic range. Make one a high dynamic red and another a high dynamic yellow. We just turn the intensity up a little bit greater than 1. We'll blend these colors together using a Lerp node, and you can find that under Math, Interpolation, Lerp. Here's our Lerp node. Make some room if you need to. The Lerp node has an A input, a B input, and a T input. Those of you familiar with the Lerp methods from the Unity Engine API know what that means. Basically, this node can interpolate between two different values or two different sets of values. In this case, we'll use two colors, but really can be any two values at all. The third input T is what we use to control the blending. And T will typically be between 0 and 1 and represents what percentage that we lerp toward the target value. And that's how I remember T, as the target. When T is set to 0, we reached 0% toward the target value. So we'll use just whatever's in the original input, input A. When T is set to 1, we'll use 100% of the target value, so we'll just use whatever is in input B. For everything in between, we do a linear blend between the two sets of values. Set this to 0.25, and you'll get 25% of the target input, input B, and 75% of the original input A. Set this to 0.5, and you'll get 50% of each, and so forth. All right, so let's plug these colors in. Drag one into the A slot, and drag the other into the B slot. For color, we have 4 sets of numbers, R, G, B, and A. So you'll see the ports change to 4 in parentheses after those are connected. And you'll also notice that our T input has 4 fields that pop up in response. They're all at a value of 0 right now, so we're favoring the top input A 100%. Switch these T values to 1, and then we favor the bottom input 100%. Change this to something in between, like 0.25, 0.25, and 0.25, and then we'll get a blend between the two. We want to push the results of the Lerp out of the subgraph. To do that, we'll need to add a slot to the subgraph outputs. Click Add Slot. Connect the output of the Lerp, and really that's the core of this subgraph. The rest is just some bookkeeping, so let's take care of that. We'll need a few properties, of course, to make this useful. Convert both of the colors to properties. Convert to property, convert to property, and let's call them color A and color B in the blackboard. And now we need to figure out what we'll use to drive our T parameter. If you want to add some simple animation, again, our basic sine node is useful here. So let's start with a time node. Input basic time. Connect that with a math basic multiply node. And we'll connect that to the A port by default. And let's hook that into a sine node. Math trigonometry sine. And if we take the output of the sine and hook that into our T input of the Lerp, then our sine wave will control the blending. And you'll see the colors start oscillating in the preview node. And it's working, but we probably want to be a little more careful here. By default, the sine wave outputs a value from -1 to 1. The timing will be a little bit off if I leave it like this, since we're expecting the t to have a value between 0 and 1. So I suggest that you add a remap node in here. That way we'll map the sine wave to run between 0 and 1. And then we'll output the remap into the lerp. And now in the preview, you'll see our color bounce between color A and color B using the natural timing of a sine wave. Add a vector 1 to the blackboard so we can adjust the frequency of the wave. And I'll just call that frequency. And yes, technically it's not the frequency, which is measured in cycles per second, but it is directly proportional, so I think the name is understood. All right, so let's drop this into the graph and connect that into the multiply. And now we can control the speed of the lerping back and forth. Turn up the frequency if you want to make the colors flash more like a police light, or dial it to something small to make the fading back and forth more gradual. Save the subgraph asset, and then let's close out of here. For your challenge, see if you can hook this into your force field shader graph. Create an extra rim color property, and then replace that plain old rim color with 2 colors and a color lerp node. And then see how your force field can have a simple animating color. Okay, it should be relatively painless. Go ahead and pause the video and try that for yourself. When you're ready to resume playback, continue to the end of the lesson. In your force field shader graph, locate where we set up our rim color. And it's right here, close to the end of the graph. Let's make some space if you need to. And then disconnect the rim color temporarily. Drop in a new subgraph node, color lerp subgraph. And the rim color will feed into this color lerp subgraph. The output of that, in turn, will go to the multiply. And we'll need another color for our color B. On the blackboard, let's create a rim color alt. Choose a nice color that contrasts with our original rim color. I'll try to make mine yellow. Switch the mode to HDR, and we can pump up the intensity a little bit. Let's drop that into the graph and then plug that into our color B. And for the frequency, we already have a control like that called the rim pulse speed. We can reuse that property if you want the colors to change with the fading in and fading out of the rim glow. Otherwise, you can always create a separate vector 1 property, control that. But I think reusing the rim pulse speed is the way to go, so I'll do that. Save the ShaderGraph asset after everything's hooked up. In the editor, press play, and now you can see the color of the rim glow changing as it fades in and out. The effect is minor, but when you're creating these shaders, you're really trying to add as much visual impact as you can. Using Lerp to animate the colors is a great way to make your shader just have a little bit more life at runtime. If the effect is too subtle, try a different color, and I can pick something with a little more contrast to the original rim color, something like that. And again, just experiment until you get something that fits your look. Now you can add this color lerp any place in your shader graphs where you normally use a single color. You could definitely modify the edge noise color in the same way, for example, but I'll leave that up to you. Okay, well, have fun with that. This is just another tool in your arsenal of shader graph tricks. Until the next one, keep on making those shaders, and don't forget to post your work in the Q&A forums.